Welcome to Geometry Notes 1.4. We're going to be looking at angles and angle measure. This video right now is on objectives 1 and 2, identifying and naming parts of an angle, and measuring and classifying angles. So these two objectives right here. We're going to start with identifying and naming parts of an angle. As a brief review of rays, a ray is a part of a line with one endpoint continuing infinitely in one direction. That direction is determined by a second point, and it's named by those 2 points, and the order of the naming matters. So for instance, this could be ray MP, ray MP with the arrow over it, ray MO, which still takes me through the same place and continues, or ray MO with the arrow over it. So we're going to review real quick. How could we name this ray? In our short version with the little arrow over it, we could have ray O, and going through I could name that by OD, ray OD. I could name that by ray OB, ray OB. There's actually just 4 ways to name this, so sorry about that. Okay, and then I could name that same ray by using the word ray. OD. O still has to come first as the end point. D is the point that gives me my direction, that's the arrow. Or ray OB. Okay, so that's 4 ways. 4 ways to name this ray. When we have any 2 rays going in opposite directions forming a line, these are called opposite rays. They form a line, so I could, for instance, have a ray, 2 pairs of rays, we'll say JH, this ray, and the ray JK. And these 2 rays together, because they're in perfectly opposite directions, they're 180 degrees on each side. They split a circle of 360 in half. The 3 points are collinear. That forms a line. And then specifically, when we have 2 rays that aren't opposite in particular, but any 2 rays sharing a common endpoint are known as angles. So here we have an angle made up of 2 rays. So the rays are the sides of the angles. We have ray or side x, y, and side or ray x, z. And the common end point is known as the vertex of the angle. The common end point is the vertex. In this case, we just say vertex x because that is a point. That's how we name a point. Okay, we always name angles with 3 points, and the vertex must be in the center. So we could name this angle either angle, that's our angle indicator, x has to be in the center, and we could name this y, x, z, or angle, again, our vertex x in the center, z, y, x, or z, x, y. All right, and when we're referring to this angle, we would call this our interior angle. That's the angle being referred to right here. So let's look at another example. We want to name the sides of this angle. So sides of an angle are rays. I'm going to have one ray and another ray. And they're going to start at the common endpoint. So both of these will start with O because both rays have to have the same common endpoint. Now one ray is O and goes through the point A, so it's OA. The other ray starts at O and goes through the point B, so that is ray OB. Which is the vertex of this angle? The vertex is the common endpoint. We see it in the names of both rays, which are the sides of the angle. We see it as the point of the angle. So this vertex is O. And then we could name this angle 2 ways, actually, not 3. 2 ways. We could technically do 4, but we're just going to use the angle notation. Angle O has to be in the center. Let's put this here. Our common endpoint must always be in the center. And then I'm going to put the endpoint from one of the sides on one side and the endpoint from the other side on the other side of the angle. I could also name this the other way around as long as my vertex O is still in the center. Angle BOA. Both of these are good. I could write these long way as angle AOB if, for instance, I'm in a situation where I need to type instead of being able to use the angle marker. All right. Then we also have ways that we describe the points around an angle. Any points that are on the angle or on the rays or sides of the angle itself are known as being on. So if they're on the rays, for instance, M, N, or Q in this case, that would be on the angle. These points are on the angle. If they are in the larger area outside the angle, then they are exterior of the angle. So we see this here with P and O. Let's get a different color here. P and O, because they're in this outer reflex area of this angle. And the points that are inside the narrow area of the two rays are interior the angle. So that would be R and S. So let's look at this example. We have first our points on the angle would be any point that is a part of the ray. In this case, we have, I believe, 5 of them. Q, which is the vertex and is also on the angle. G and P, which are points on this ray, as well as E and R, which are points on this ray. Okay? Then points interior the angle are going to be within the narrow space between the two rays. So I have A, D, and F are points interior of the angle. And then my points exterior of the angle are going to be at the outside big space out here, which will include point B and point C. Okay, then we're going to look at the measure and classification of angles. So when we measure angles, there are actually 2 ways to measure angles, primarily. One is in degrees, and this is what we're going to use in geometry. You will use these in Algebra 2 and Pre-Calculus to some degree. In Algebra 2 or Pre-Calculus, you'll be introduced to radians. Radians is an arc length equal to 1 radius. We're not going to go into detail with this. We're not going to use it at all in geometry, but I just want you to know there is another type of measure coming up in the future. For now, we're going to use degrees, which is 1/360th of a circle. So if we took the entire way around, split that up in half, makes that 180. We could split that again, and each of these have 90. These are known as our quadrants in algebra. If we split each of these in half, then each of these little sub-pieces are 45. And if we could split that maybe into thirds, then each of one of these little pieces is about 15. And you keep subdividing until you have 360 little indicators. And one of those little 360s is 1 degree. And then we classify our angles based on the number of degrees it has. So the first one you're probably very familiar with. These are acute angles. And an acute angle has a measure greater than 0. Oops, did that the wrong way. Greater than 0, but less than 90. So if we were to look at a little right angle marker, this is going to cut into that right angle marker. This right here could be an acute angle. Might help to highlight that this is the acute angle we're talking about here. We could also have an acute angle. It doesn't have to be lined up just like that. It could be more like this, and then that is my acute angle. Right? And then we have this little right angle marker when we have an angle that is exactly 90 degrees, then our angle is a right angle. And for this lesson only, we're going to go off of, does it look like a right angle? Then we're going to say, yeah, we'll assume that's a right angle. After this lesson, we can't assume. Right now, we're just practicing, do we understand when it looks nice and square that that is a right angle? Okay. We know for sure that it's a right angle if it has the little square marker in it. That literally means right angle. After an angle expands beyond that 90-degree mark, so if my angle is larger than 90 degrees, but still less than half a circle, 180 degrees, then it is an obtuse angle. So greater than 90, less than 180. And if we were to draw a nice straight line with my right angle marker, then this is going to be something that expands way out past the right angle, does not cut it at all. Then that would be an obtuse angle. We could also have that drawn a little more freehand. Something like this would be an obtuse angle. Now notice it's going to be greater than 90 degrees, but less than 180, so it's not going to go past this flat straight line. When we have an angle that expands to become exactly 180 degrees, we call that a straight angle. And this is our opposite rays. So as long as it looks like a perfectly straight line, that would be a straight angle. And I actually have a straight angle on the top and a straight angle on the bottom because the top is 180 and the bottom is 180 degrees. So that'd be a straight angle. And then we do have a special kind of angle for anything that extends beyond 180 is called a reflex. A reflex angle. So this is for x is, space that out a little bit, x is greater than 180 but still less than 360. There's a special term you might learn in Algebra 2 or Pre-Calculus for greater than 360, but we're just going to focus on our reflex angles. And this is when I take my second edge and instead of it being acute, instead of it being right, instead of it being obtuse, instead of it being straight, I stretch it past straight so that it's down here, but I'm still taking the larger than 180 measure, not this smaller area in here. Nope, I want to like cross that out. Not in here. We're talking about this large exterior angle. Okay, it's not an exterior angle, it's a reflex angle. This reflex angle when something's larger than 180. We won't deal with these a lot, but I want us to be aware that a reflex angle is when we've stretched our arm really further than it can go at our elbow here. So that is a reflex angle greater than 180 degrees.